Hello, my name is Reinhard, and in this video I'll walk you through setting up and using the Fidelix FDX Compact AI8C analog input module. We will learn how to install the hardware, what the indicator LEDs signify, how to connect and configure inputs, how to parameterize the different types of inputs, and how to communicate using a third-party Modbus client. At the end, we'll go over some tips and tricks based on our field experience. The AI8C module can be used to measure different analog signal types: 0 to 10 volts tension signals, 0 to 20 milliamps current signals, and resistance. A resistive input can also be used as a digital input to detect opened or closed circuits. The Modbus address of the module is set using the dip switches at the side of the module. The module is powered and communicates through the T-bus connector, which is clicked onto the DIN rail. 24 volts DC and the Modbus RTU over RS485 communication, A+ and B- are passed through here, and the module itself simply clicks onto the T-bus connector. Once powered, the LEDs will indicate the startup sequence of the firmware of the module. Connecting analog inputs is not complicated. Depending on the input signal type, you will connect the wires of your sensor as follows. Passive measurements with resistive properties or digital inputs are always connected with two wires. A reference voltage is set over the sensor between the numbered connectors and the ground connectors. Simply connect your sensor between those two. From active sensors that require their own power supply, the measurement's input signal should be connected to the numbered connectors. Make sure the ground level of the power supply of the module and the sensors are connected to get accurate measurements. You can do this by simply using the same power supply or by connecting the sensor's ground level to the GND connector on the module. The ground connectors are all connected to the ground level of the power supply of the module. For easier installation, or when your field device requires another voltage than 24 DC, an external supply voltage can be connected to the auxiliary connectors. These form a galvanically isolated circuits all connected to each other, meaning you can use the aux loop to power several sensors. For two-wire current measurements, the supply voltage, 24 volts, is taken from the auxiliary connectors, and the signal wire, combined minus or ground wire, are connected to the numbered sockets. As I already mentioned, the ground connectors are all connected to the bottom power supply's ground, provided through the T-bus connector. Similarly, the DC connectors offer a connection to the 24 DC plus of the power supply, which is of course also provided through the T-bus connector. You can use these connectors just like the auxiliary connectors to power field devices. Just make sure to not draw too much current through the module. Also, bear in mind that if your field device malfunctions and creates a short circuit, you risk damaging the module itself also, as well as any other devices connected to the same power supply. So use the DC connectors carefully. The connectors are spring-loaded. That means for hard, one-wire cables, you can simply push the cable in to connect. To connect multi-wire cables, push the colored button with a small flat screwdriver before inserting the cable. Pushing the button opens the spring cage terminals, so insert your multi-wired cable while keeping the button pushed, and then release the button so the spring cage grabs onto your cable and it is connected tightly. With FX Editor, each of the 8 inputs can be individually configured depending on their input types. Measurement inputs are at 20-bit resolution. The sensor type is easy to choose at ready lookup tables. There are the following sensor types integrated into the firmware: pure resistance measurement, NTC10, PT1000, NTC20, Nickel 1000 LG, and Nickel 1000 DIN sensors. With third-party solutions, the sensor type can be set in the Modbus registers. With FX Editor, it is possible to make any kind of sensors lookup table. For voltage measurements, the input signal value will be scaled to the desired measurement unit. Input's raw values are between 0 and 100,000. So for example, the measurement of a 0 to 6 bar pressure is done using the following conversion table. 0 or 1 on the x-axis is translated into 0 bar on the y-axis. Similarly, 100,000 on the x-axis is translated into 6 bar on the y-axis. Configuring current inputs is done similarly. Only the 4 to 20 milliamps signal comes in as a value between 16,000 and 80,000. Digital inputs are configured like normal DI points, simply linking the point connection to an AI module's input. More about that can be found in the lesson covering the DI16C module. The type of input is configured in the point programming in FX Editor. In the settings of each conversion table, called lookup table, there is a parameter called spider/compact type. The selection must correspond to the type of input you are using. When using the classic analog input I/O module, this selection is done by putting the jumper on the pins. Possible options are resistive, 0 to 10 volts, or 4 to 20 milliamps. When using a third-party Modbus client, the unused points are configured as resistive, as the sensor type registers are set to 0. The input type selection is indicated by the LEDs on the status panel of the module. The LED next to U indicates the measurement signal type is voltage. I means the measurement signal type is current. And if neither of the LEDs are on, the input channel is in resistive mode, which is also how it can be used for digital indications. Using another Modbus client than our FX controller, consult the detailed documentation about the Modbus communication interface. All parameters you can set using FX Editor can also be configured using the module's Modbus registers. Measurement values are thus available either directly from registers 22 through to 29, or when 20-bit accuracy is needed, as values between 0 and 100,000 from registers 0 through to 9. The most common mistake is selecting the wrong input type for one or more input channels. It is very important that all of the inputs of the module are configured correctly, as this selection makes the right physical connections on the circuit board. Making a wrong selection can thus cause all the measurements of your module to return faulty values, or at least unpredictable ones. Another good tip is that the analog input module can also be used as digital input, not for fast inputs like pulse or tacho measurements, but it is useful in cases that all of your digital input modules are full and you need one additional point. That way, you don't have to add an additional DI16 module. You now know how to install, configure, and parameterize the Fidelix FDX Compact AI8C analog input module, and you can start connecting all of your devices. Please check out our other videos and Academy lessons to learn how to use other I/O modules. If you need more information, or if you have other questions, you can find out everything about all Fidelix products and services at support.fidelix.com.